Hello, welcome back. Today we're going to look at special right triangles. We're going to look at the 30, 60, 90 and the 45, 45. I was feeling a little wacky today and I drew my little robot. So we have the 30, 60, 90. Opposite the 60-degree angle, we have radical 3/2. Opposite of the 30-degree angle is 1/2, and the hypotenuse is always 1. For our 45, 45, the two legs are going to be the same because it's a 45, 45 degree angle. So radical 2 over radical 2, again, the hypotenuse is 1. So those are our two special right triangles. I quickly just want to go over where they came from. So the 30, 60, 90, it just comes from half of an equilateral triangle. So let's say you had a triangle that had all three legs were of length 1. So if we cut this triangle in half, we end up cutting one of the legs into half. And now we can use the Pythagorean theorem to figure out what the third leg length is. So we have 1/2 squared plus x squared will give you 1 squared. So if we solve this equation for x, we get 1/4 plus x squared equals 1. Subtract 1/4, you end up with x is equal to 3/4. You take the square root of both sides, and so you end up with the square root of 3/2, which is that third leg on our 30, 60, 90 triangle. So now let's take a look at where the 45, 45 triangle comes from. And this just comes from a square. So a square, if you just cut it in half, if you have a square that has all sides of equal 1, you cut it in half and you use Pythagorean theorem. So you have 1 squared plus 1 squared equals x squared. When you solve for x, you end up with the square root of 2. So to make it look like our special right triangle, you just divide all three sides by the square root of 2, and that way the hypotenuse is equal to 1. And that's it. So that's all for today. Thanks for watching.